Problem number 1. Evaluate integration of e raised to the power 10 inverse of x whole divided by 1 plus x squared dx. So here we are going to suppose that 10 inverse of x is equals to y, and then we are going to differentiate both sides with respect to x, and that should give us dx over 1 plus x squared is equals to dy. So our original integral becomes integration e 10 inverse x over 1 plus x squared dx can be rewritten as integration e raised to the power of y dy. Here we have replaced e raised to the power of 10 inverse x with e raised to the power of y and dx over 1 plus x squared with dy. So the integration of the exponential function e raised to the power of y with respect to y gives us e raised to the power of y plus the constant of integration c. Therefore finally we get e raised to the power of 10 inverse of x plus c. Problem number 2. So here we have to integrate secant squared t divided by tangent of t dt. So we're going to suppose that tangent of t is equals to y. We're going to differentiate both sides with respect to t. So differentiation of the tangent function with respect to t gives us secant squared t, which is equals to dy over dt. Rearranging, we get secant squared t times dt is equals to dy. What we're going to do, we're going to consider the original integral. We have integral secant squared t dt over 10t. So that will become integration dy over y, and integration of 1 over y is natural log of y plus c, and that finally gives us the natural log of tangent of t plus c. Problem number 3. So here we need to evaluate the integral dx over e raised to the power of x plus 1. What we're going to do, we're going to consider the function 1 over ex plus 1, and we're going to multiply the numerator and denominator by e raised to the power of negative x, such that the integration now becomes integral dx over ex plus 1 can be rewritten as integral e raised to the power of negative x divided by 1 plus e raised to the power of negative x, and we're going to integrate it with respect to x. So let this be equation number 1. Now let 1 plus e raised to the power of negative x be equals to 2. So we're going to differentiate both sides with respect to x, and that should give us negative e raised to the power of negative x dx is equals to dt. So that equation 1 can be rewritten as integral negative dt. So we have replaced e raised to the power of negative x dx with negative dt divided by t. So that should give us negative log of t plus c, which is the constant of integration. So we can take care of the negative sign and we can rewrite it as natural log of 1 over t plus c, replacing t with the original value. So we have natural log of 1 over 1 plus e raised to the power of negative x plus c, and that finally gives us natural log of e raised to the power of x divided by e raised to the power of x plus 1 plus c.